We are going to be looking at lesson 7-5 together using proportional relationships. We're going to be learning some cool stuff in this lesson, and I will try to scoot through it. The first thing we're going to talk about is indirect measurement. That is any method that uses formulas, similar figures, and or proportions to measure an object. The following example shows one indirect measurement technique. And y'all, I just think this is so cool, and you'll have some homework problems like this as well, maybe even test questions. So this is example 1. We are on page 488, and we are looking at measurement application using indirect measurement. A student wanted to find out the height of a statue of a pineapple in Nambour, Australia. She measured the pineapple's shadow and her own shadow. The student's height is 5 feet 4 inches. What is the height of the pineapple? So let's look at the picture. The student's height is 5 feet 4 inches. I've written that very lightly right there. And her shadow is 2 feet long. The pineapple's shadow is 8 feet 9 inches. And we are looking for the height of the pineapple. All right, when we have mixed measures like 5 feet 4 inches, we cannot easily do math with that. So we need to switch that all into feet, like a decimal number, or all into inches. And I would much rather switch it into inches. So 5 feet 4 inches is equal to 64 inches. All I did was count by 12 5 times. That gave us 60 plus 4 inches is 64 inches. I did the same thing with the girl's shadow and the shadow of the pineapple. And now you're going to be very familiar with what we're doing. We're simply going to set up a proportion to solve for DF. So for my proportion, I chose to do the shadow of the girl to the height of the girl and set it equal to the shadow of the pineapple to the height of the pineapple. So I have 24, or shadow of girl, is to 64, height of girl, in the same way, or as 105, the shadow of the pineapple, is to the height of the pineapple. So 24 over 64 is equal to 105 over x. We're going to cross multiply and solve for x, and x is equal to 280 inches. All right, let's look at the check it out. This is check it out number 1. A student who is 5 feet 6 inches tall measured shadows to find the height, LM, of a flagpole. What is LM? Here's our student, here's our flagpole, and here are our shadow lengths. So again, I've changed all of this to inches because of the mix of feet and inches in these two parts. So I'm going to set up a ratio, and I'm going to say the length of the shadow is to the height of the guy, as the length of the flagpole is to the height of the flagpole. So again, length of shadow, height of guy, length of flagpole, length of shadow of flagpole, height of flagpole. And don't forget that we changed 5 feet 6 inches to 66 inches, 5 feet to 60 inches, 4 feet 2 inches to 170 inches. So that's where all of those numbers came from. And then we simply cross multiply, solve for x, and the height of the flagpole, LM, is 187 inches. All right, moving on to the next section. We are now going to talk about scale drawings. A scale drawing represents an object as smaller than or larger than its actual size. The drawing scale is the ratio of any length in the drawing to the corresponding actual length. For example, on a map with a scale of 1 centimeter to 1,500 meters, 1 centimeter on the map represents 1,500 meters in actual distance or in real life. So let's try applying that. Actually, maybe we should run through that definition one more time. And I'm not going to keep moving my phone this time. Y'all can follow along in your book. But let's just go through it one more time. A scale drawing is a representation. It represents an object as smaller than or larger than its actual size. The drawing's scale is the ratio between the two. It's the ratio of any length in the drawing to the corresponding actual length in real life. For example, on a map with a scale of 1 centimeter to 15 meters, every 1 centimeter on the map equals 1,500 meters in actual distance. All right, just wanted to make sure you had a handle on that and good understanding before we move on to apply it. Solving for a dimension. The scale of this map to the right, which you can see in your book, of downtown Dallas is 1.5 centimeters to 300 meters. That means on the map, a length of 1.5 centimeters is going to be equal to 300 meters in Dallas. Find the actual distance between Union Station and the Dallas Public Library. Well, the first thing that we need to do is we need to get out a ruler, and we need to use the centimeter side of the ruler to measure between Union Station and the Dallas Public Library. So from Union Station to the Dallas Public Library, we would measure 6 centimeters. From there, we can start to get our ratio because the problem told us that the ratio of map to real life is 1.5 centimeters to 300 meters. So I've written, and I actually have it on the left of my problem, 1.5 centimeters on the map to 300 meters in real Dallas. And then I'm going to compare that to the distance that we measured on the map, which was 6 centimeters, and I'm going to put that over our unknown actual distance in Dallas. So 6 on the map is to the unknown distance in Dallas in the same way that 1.5 centimeters on the map is equal to 300 meters in Dallas. All right, let's solve. We're simply going to cross multiply. 1.5 times x equals 6 times 300. You can see my math. I solved for x, and it's 1,200 meters. So that is how far the actual distance from Union Station to the Dallas Public Library would be. Okay, that's all I'm going to do with that one. Let's move on to the last, actually I don't think this is the last example. Let's move on to example 3 though. Making a scale drawing. So we just learned about understanding and reading a scale drawing. Now we're going to learn about making one. The Lincoln Memorial in Washington, D.C. is approximately 57 meters long and 36 meters wide. And we're talking about the base of it. Make a scale drawing of the base of the building using a scale of 1 centimeter to every 15 meters, or 1 centimeter to 15 meters. So 1 centimeter on your paper is going to equal 15 meters of the Lincoln Memorial. So let's look at how to set this up. We know that the ratio is 1 to 15. We also know that we have length for the Lincoln Memorial and we have width for the Lincoln Memorial. However, we are going to have to solve them separately, each using the same ratio of 1 centimeter to 15 meters. So let's start with our length. You can see that length on your paper is to 57 meters at the Lincoln Memorial, as 1 centimeter on your paper is to 15 meters at the Lincoln Memorial. So on the right is the scale that we were given. On the left is the comparison to the length that you're going to draw versus the length that actually exists. These are the same kind of proportions that you're already used to setting up. We're going to solve by cross multiplication as always, or solve a proportion by cross multiplication. And we're going to find the L, or the length on your paper in your scale drawing, is going to be 3.8 meters. Now let's do the same thing with the width. Our ratio that we were given is 1 to 15. I have that on the right. And on the left, I have the width of the scale drawing that I'm going to make over the 36 meters that's actually the width of the Lincoln Memorial. So scale drawing to Lincoln Memorial is to, or scale drawing is to Lincoln Memorial as scale drawing is to Lincoln Memorial. The information we're looking for over here equal to the ratio that we were given over here. And we're going to cross multiply. 15W equals 36 and W equals 2.4 centimeters. All right, from there, you would simply grab your ruler and you would draw a rectangle to those very dimensions. And I think that we can stop there. I was trying to decide if I was going to do one more of those. I think I will. I'll just run through this one quickly. All right. A rectangular central chamber of the Lincoln Memorial is 74 feet long and 60 feet wide. This is the check it out, by the way. Make a scale drawing of the floor of the chamber using a scale of 1 inch to 20 feet. Okay, so for solving each dimension, we need to solve width and we need to solve length. I put X for length, but I really should have put L just to make it less complicated. On the right side of both, I put our dimension that was given. And on the left side of both, using the smaller to larger approach, just like this, I put the X that we need to know, which is our length for our drawing, our scale drawing, and then underneath it is the length of the actual Lincoln Memorial chamber. And then I did the same thing with the width. The width of my scale drawing is to the width of the chamber as 1 is to 20. That's the proportion. Then I solved for length and solved for width, and I think that's pretty self-explanatory. All right, I'm going to end this video there, and I'll start with a second video for lesson 7-5 in just a minute.